What are organic chemicals? This video is an introduction to organic chemistry. So in this video you're going to find out what we mean when we say organic chemicals, and we're going to look at specific types of organic chemical. In this video we are going to talk about a substance called crude oil, and you may know something about crude oil. You should have learned about fossil fuels earlier on in your science lessons, and crude oil is one of the 3 fossil fuels. So what I'd like you to do to start off this tutorial is have a look at the diagrams on the right hand side of this slide. These are displayed formula of lots of different chemical compounds. Next, I would like you to read the information on the left hand side of this slide, and I will give you some time to do that, so you should pause the video now so that you can try and understand what's being said in that passage. Now, to check your understanding of the information in the passage, on the next slide I'm going to ask you a series of questions. So if you get a Google Doc or a Word document or a piece of paper ready, I would like you to answer the questions on the following slide based on the information on this slide. Of course, if you're stuck, you can always go back in the video, read through this passage again and use it to help you to answer the questions. So these are the questions I would like you to answer now based on the passage on the previous slide. Question 1. What is the same about all of the compounds in crude oil? And I've put the diagram up on the top right of this slide just to help you out with that. There are no silly answers, so if it seems obvious to you, just write it down, you might be correct. Question 2, what is different about all of the compounds in crude oil? Question 3, what name can be given to all the compounds found in crude oil? Question 4, is this a mixture? If so, why? If not, why not? Question 5, what is the special name given to the hydrocarbons found in crude oil? Question 6 asks you to give names to these specific alkanes or these specific compounds. So if you're unsure, go back in the video and have a look at that passage again. And question 7, by what process can these be separated? So pause the video now, spend some time answering these questions, and make sure you're paying attention to the number of marks available. If there's more than 1 mark available, it would be sensible to give more than 1 answer. So pause the video now and work through your questions. Okay, so we're now going to review the answers to your questions. So if you did these on paper and you've got a different colour pen, that would be a good idea to get hold of now so that you can mark your answers. If you're doing this on Word or Google Docs, maybe choose a different colour font so that you can write in any corrections to the questions that you may not have got correct. So question 1, what is the same about all of the compounds in crude oil? Well, if we take a look at these up here, each of these is a different compound, well, not necessarily different, but is a compound. So here's a compound, here's another compound. So if we just take these 2, for example, we can start to look at the similarities and differences. So what I can see that's similar between this compound and this compound is that they both contain carbon, and I can see that they both contain hydrogen. I can also see that they have only single bonds, but I think the most obvious ones at the moment would be that they contain carbon and hydrogen. Okay, question 2 says what is different about all the compounds in crude oil. So I'm going to pick you out 3 compounds so that we can compare them a little bit more easily. Okay, so here I've circled one of each of the different types of compounds that we've got within this mixture. So I can see straight away that there is a difference between them, and one of the differences is size. So this compound here is much smaller than this compound here, for example. So size would be a good answer. We can also talk about size in terms of how many atoms they've got in them. So the number of carbon atoms, so this one's got 1, this has 2, and this has 3. Or the number of hydrogen atoms, this one has 4, this one has 8, and this one has 6. So they have different number of carbons, they have different number of hydrogens, they are different sizes. You could talk about size in terms of length, so you could say they have different lengths if you want to as well. So they're all the things that are different. So I've put size, length, number of carbon atoms, and number of hydrogen atoms. Question 3, what name can be given to all the compounds found in crude oil? If you go back to your passage, you'll be able to find that in on the previous slide. So these compounds are all called hydrocarbons. They are also all alkanes. So if you put hydrocarbons, you can have a mark. If you put alkanes, you can also have a mark, because they are actually all alkanes as well. Question 4, is crude oil a mixture? Straight away, yes it is. And it is a mixture because it is made of different size molecules, different types of molecules or different types of compounds, and they are not chemically joined together. So this compound here is not chemically joined to this compound. We can't see anything sticking it together, and it's not chemically stuck to this one or this one or this one. So they can actually be separated. So you could pull this one out and pull that one out and pull that one out if you use the right sort of separation technique. So the compounds are not chemically joined together and they are different. So it's a mixture. All right, question 5. What is the special name given to the hydrocarbons found in crude oil? We've already said it before for one of the previous questions. They're hydrocarbons, but these specific type of hydrocarbons are called alkanes. Now, don't worry if this is all new to you, because this is a new topic. Alkanes, hydrocarbons and all that, we're going to come to some definitions of those so that you can use those words in your work. But for now, it's just a bit of comprehension to check you understood the information on the previous slide. Okay, question 6. Name these alkanes. Well, if you're to read the information on the previous slide, it tells you the name of the alkane with 1 carbon in it, with 2 carbons in it, and with 3 carbons in it. So the smallest one that has only 1 carbon in it is called methane. The next biggest one up with 2 carbons is called ethane, and if it has 3 carbons, it's known as propane, which is the same as the propane that you sometimes get in a gas bottle. If you've had a barbecue lately, you might have a propane gas bottle lying around somewhere. So methane, ethane and propane, they have to be in that order. And question 7, by what process can these alkanes be separated? It's a process known as fractional distillation. And there's all your answers. So if you just go through those, and if there's anything that you didn't get right, check that you understand. If not, you can get in touch with me. You can leave a comment or something like that. But just correct your answers for now, because it might come in handy later on in the lesson. Okay, so we've got a lot of new keywords. So here's a key definition that you need to learn, and this one is hydrocarbon. So a hydrocarbon is a molecule that is made up of hydrogen and carbon only. I'm putting that in red because it's important, because people always miss it out. This is quite an important word, because if you've got a molecule that's got hydrogen in it and it's got carbon in it, it's only a hydrocarbon if there's nothing else in it. So as soon as there's another element in there, it cannot be classed as a hydrocarbon anymore. So if you're asked in an exam, what is a hydrocarbon? First of all, be very careful here. You can say molecule or you can say compound, but you cannot say mixture, because something like this, let's draw a hydrocarbon. This is not a mixture, because that H is bound to that C is bound to that H. It's chemically stuck together, chemically bound together. So it's a compound or a molecule. It's not a mixture. So make sure you get that bit right. Made up of hydrogen carbon is nice and easy, because the clue's in the word, hydrocarbon. And the word only is really, really important, so stick that on the end as well. Okay, so hydrocarbons can be all sorts of shapes and sizes, and that is why there's an entire branch of chemistry devoted to organic chemistry, because carbon can bond to itself in so many different ways, so many different patterns, and can incorporate loads of other elements as well to make its compounds. So hydrocarbons alone, there are tons of them. So it's important that we know what they are before we move on, because that's what we're going to be looking at throughout this entire topic. Now, if you have your paper in front of you, you're making some notes, this would be a definition that I'd write down. So if you need to do that, you can pause the video now before we move on. Okay, so I'm going to give you a little bit of information about hydrocarbons, things that you need to know about this group of compounds. So split this into a number of questions. What do they look like? Where do we get them from? And why do we need them? I'm actually going to start with the last one. Why do we need them? Hydrocarbons, the reason we're learning about them, the reason they are valued by society, is because they are absolutely vital to our way of life. Hydrocarbons are used as fuels, particularly portable fuels. So I was suggesting propane is what you get in a gas bottle that you use with your barbecue, but also stuff that's fixed as well that isn't portable, methane, the the gas that supplies your cookers at home, that is methane gas, similar to the gas supplies that are in school in the gas taps. So fuels for both portable purposes and home and schools as well. They are really, really important. They're also used, hydrocarbons, for making other chemicals, particularly useful for making plastics. So we can make plastics out of hydrocarbons and we can burn them for fuel. So they are essential. We do need them. Other fuels that are made of hydrocarbons are things like petrol, diesel, kerosene, which is used in planes, fuel oil, which is used to power big boats and ships. So they really, really are essential. So if that's what we're using them for, where do we get them? Well, our fuels, the ones you will have heard of, are fossil fuels. And coal is more carbon rather than a hydrocarbon. Coal doesn't have as much hydrogen in it, or actual coal is just carbon. So we're looking at oil and natural gas. And you may have noticed from the starter that I asked you to do, the text that I asked you to read, crude oil is what we're really interested in. So we're going to have a little look at crude oil in a moment. So we tend to get them from fossil fuels such as oil and natural gas. What do they look like? There are various ways that you can represent hydrocarbons. You've already seen some hydrocarbons drawn out, so I'm going to show you some different ways to represent them as well. So in terms of chemical representation, you can have what we call a displayed formula. A displayed formula is when you have all of the atoms shown and the bonds between them. So when I showed you methane looking like this, that is the displayed formula for methane because it shows you all 5 of its atoms, the carbon and the 4 hydrogens, and it shows you how they're laid out with the bonds between them as well. So you could use displayed formula, which is really useful. In chemistry, we also have what's called molecular formula, and that's the normal chemical formula that you're used to seeing. So if we stick with our methane example that we've got here, we can see it's got a carbon and 4 hydrogens. So if we were going to put that into a chemical formula, it would be C with no numbers after it because it's just one of them, H with a 4 after it because there are 4 of them, so that's a molecular formula. Other ways that you can represent them in terms of chemistry are using models like a ball and stick model. So a ball and stick model is like a 3D model of the displayed formula essentially, so it'll show the carbon in the middle and the hydrogens around the outside. So your ball and stick model might look something like that, or you might have a slightly more 3-dimensional representation showing how the hydrogens are arranged around the outside of the carbon atom. Now in reality, when I say what do they look like, they don't really look like this or this or this. If you were to have a jar of methane, you wouldn't even be able to see it. It's just a colourless gas. Same with propane and things that come in a gas bottle, it's just a colourless gas. If you've turned a gas tap on in the science lab, before you manage to light the Bunsen burner, you realise that you can't really see anything coming out of the Bunsen burner. It's just an invisible gas. So that's what they actually look like. Some of the bigger hydrocarbons aren't gases. Some of the bigger hydrocarbons are liquids. So if you've ever seen petrol or diesel or certain types of fuel oil, then that's what those hydrocarbons look like. But they're the main things that you need to know about hydrocarbons. They also come in families, so there are certain groups of hydrocarbons and you need to know about some of those families. In this video we're going to look at one family in particular called the alkanes, and then later on you will come across some other families of hydrocarbons as well. So if you're making any notes, I think a mind map is a pretty good way of laying out this information, because then you can group together all of the different ways of representing a hydrocarbon under this branch, and the different places we can find hydrocarbons under this branch and so on. So I think a mind map is a pretty good way of doing that, but if you'd like to write out notes or bullet points, then feel free to make your notes however you like. So before we start looking in a little bit more detail at things like this, like methane, let's just mention this oil. Just it's something that a lot of people know about, but just to make it a little bit more explicit. So you may have seen one of these before. This is an oil rig, and they are seen out at sea. and what they do is they put a drill down into the seabed. So from the oil rig platform here, a drill goes down through the sea all the way down to the bottom where the rock is and into the seabed, where there's usually a pocket of oil which has been identified, and then the oil rig's been built above. So crude oil is found underneath the sea floor, in amongst the rocks in these little pockets, and oil rigs are used to drill down to obtain it, and then it's pumped back up to the oil rig where it's then shipped off to wherever it's going to be used. Before it can be used, because the crude oil is a mixture of lots of different hydrocarbons, it does need to be separated by fractional distillation, but we'll come to that a little bit later. So just a reminder, as we're talking about crude oil, the crude oil is a sticky, thick, black mixture, like a tarry sort of sticky mixture. But if you were able to look closely enough, you would see that it is consistent of all of these different hydrocarbons, like the ones we've got here, but also much, much longer hydrocarbons as well. To keep it simple, these ones are only methane, ethane and propane and only go up to 3 carbons long. But some of the hydrocarbons in crude oil can go up to kind of 70, 80 carbons in a row. Really, really huge molecules, which is why the smaller ones like these are gases, and then they become liquids, and then they get thicker and thicker as they get bigger and bigger. So that is crude oil. So time to test that you understand what we mean by the term hydrocarbon. I'm going to show you, I think it's 10 compounds, and I want you to decide, is this a hydrocarbon or isn't it? And I'll tell you if you're right. So first of all, is this one a hydrocarbon? If you're doing this on paper, you could just write yes, no, or true or false or whatever as you go through. But I'll pause for just a few seconds and then I'll tell you the correct answer. So have a think about this one. Well, this compound here is a molecule that's got carbons in it, it's got hydrogens in it, and it doesn't have any other elements in it, so it must be a hydrocarbon. Number 2, is this a hydrocarbon? Again, this one has carbons in it and it has hydrogens in it and nothing else, so this is a hydrocarbon. Number 3, is this a hydrocarbon? You have to take care with this one because here we've got a carbon, we've got hydrogen, a hydrogen and a hydrogen, that's great. But this is not a carbon, this is a chlorine atom. So this one has got chlorine in it as well. And because of this, it's not a hydrocarbon. Okay, your next one, is this a hydrocarbon? There are a lot of atoms in this molecule, but they are only carbon and hydrogen atoms and nothing else. So this one is a hydrocarbon. Is this one a hydrocarbon? Well, this one's got carbon atoms in it, it's got hydrogen atoms in it, it's got no other elements in it, so this one is a hydrocarbon. Where people might get confused is just here, because what we've got is a double bond, and that's absolutely fine. We can have a double bond, still a hydrocarbon, because it's still only got carbon atoms and hydrogen atoms in there. Here's your next one, is this a hydrocarbon? Well, this one's got carbon atoms, it's got hydrogen atoms, but it's got another element as well, it's got an oxygen atom, so this one is not a hydrocarbon. Next one, is this a hydrocarbon? Again, with this one, we've got carbons and hydrogens, but we've also got an oxygen, so that one cannot be a hydrocarbon. Is this one a hydrocarbon? Well, it's only got carbon atoms and hydrogen atoms in it, so yes, it is a hydrocarbon. What about this one? Is this one a hydrocarbon? It does have a double bond, but we know that that doesn't matter. What does matter is that it's got an oxygen atom. So this one cannot be a hydrocarbon. Is this one a hydrocarbon? So this one has got carbon atoms, it's got hydrogen atoms, and it doesn't have any other elements in it. It does have a double bond, but we know that that's okay. It doesn't matter whether it's got single bonds, double bonds, triple bonds. If it's just carbon atoms and hydrogen atoms, then it is a hydrocarbon. So well done if you got those right. Now we're going to have a look at families of hydrocarbons and pay attention particularly to alkanes. Okay, so here we've got two hydrocarbons. I know that they're hydrocarbons because they've only got carbon and hydrogen in them, but the main difference, obviously there's a size difference, there's a number of carbons, number of hydrogens, but there's a big feature difference in here in that this one on the right has a double bond. That means that these two are in two different families of hydrocarbons. We have hydrocarbons that have all single bonds, and these are known as alkanes. And then, just to be really confusing, these ones on the right that have a double bond, if there's a double bond in a hydrocarbon, it's called an alkene. And that's the only difference. So you have to be really, really careful. Alkenes have a double bond between two carbon atoms. Alkanes have single bonds only. And for the rest of this, we're going to concentrate mainly on alkanes. We might bring alkenes in a little bit, but we're hardly going to mention those really. So we're looking at carbon and hydrogen only and all single bonds for these particular hydrocarbons. So we've got another key definition. If you want to write it down, feel free. It wouldn't be a bad idea. This time it's alkane. So an alkane is a saturated hydrocarbon that has only single bonds. So alkanes have only single bonds. Now, this term saturated just means only single bonds. It's the same thing. So I've put it into the key definition, the keyword definition, just because if you see the word saturated, you do need to know what it means. So saturated and single bonds is the same thing. As soon as a compound has more than one bond, so it has a double bond or a triple bond, then it would be considered to be unsaturated. So you need to know what those words mean. So this is kind of two definitions in one. You need to know what an alkane is. You also need to know what the word saturated means. Okay, make sure you get those the right way around. So if you want to pause the video and write that down, feel free. And then we're going to have a look at some alkanes, some saturated hydrocarbons. Okay, so this is the family of alkanes, and we've got the first four members of this family, the smallest four. These can get bigger and bigger and bigger. These can be absolutely huge. There's absolutely millions of them. But we're going to concentrate on just the first four because they have specific names and you need to know what they are. So looking at the molecular formula here, we need to fill in this column with how many carbon atoms are in it. So looking at this formula here, how many carbon atoms are in methane? Correct answer is 1. The displayed formula on the opposite side, if you remember what we said was displayed formula, that's when you draw this molecule out with all of its bonds. So let's draw that. We've got the carbon always goes in the middle and the hydrogens always go around the outside, like that. So there is your example. We have to write how many carbons are in it, what's its name, I've given you the names in case you don't know them, then the molecular formula, and then the displayed formula at the end, all drawn out. Now, some really important helpful advice at the top. So the simplest hydrocarbons form a series of compounds known as alkanes. That's what these are. These all consist of carbon and hydrogen only, and every carbon has 4 single covalent bonds. So if you're going to draw out some displayed formula over here, if you draw something and you think it's correct, you can check by making sure that every carbon is making 4 single bonds. If it isn't, you've gone wrong somewhere, you need to make sure that you check it again. But generally, they have the carbons in the middle and the hydrogens go around the outside. So what I'd like you to do now is to pause the video. You can draw this out as a table if you like, or if you don't have a ruler on you don't want to mess it up, you can just write it in rows or in sentences. I would like you to complete the rest of this table. So I would like you to be able to tell me what goes in each of these boxes. So if you could do it on your work now and pause the video, we will go through it and review it in a minute. Okay, let's have a look at some of these then. Hopefully you've already completed it and you've paused the video. If not, quickly do it now. let's have a look at the second one. So the second one is called ethane, and its molecular formula is given as C2H6. So from this, how many carbons does it have in it? It has 2 carbons. And its displayed formula, well, we know it's got 2 carbons in it, so I'm going to draw 2 carbons and stick those together. And I know that it has 6 hydrogens. So if each carbon makes 4 bonds, we've got 1 bond already between the 2 carbons, 2 bonds here, 3 bonds here, 4 bonds here. So I'm going to stick some hydrogens on the ends of these. And then the other carbon also needs to be making 4 bonds. It's already making 1 to the other carbon. There's 2, 3, and 4. Let's put hydrogens on the end of those. So is each carbon making 4 single covalent bonds? Yes, it is. And do we have 2 carbons and 6 hydrogens? So we need to check this. Yes, we've got 2 carbons and we've got 6 hydrogens, so that's correct. Second one, the third one down, we've got propane, which is C3H8. The formula is C3. It tells us we've got 3 carbons, so we'll draw 3 carbons in a row. Right, the carbon on the left is already making 1 bond and it needs 3 more. So we'll stick some hydrogens on the end of those. Carbon in the middle is already making 2 bonds, making 1 to the left and 1 to the right. So we'll do 1 up and 1 down. And we'll put hydrogens on the end of those. And the one on the right needs 3 more bonds, so we'll draw those in and we'll stick hydrogens on the end of those. So all of our carbons are making 4 single bonds. We have got the 3 carbons and we need to check we've got 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. And for butane, this tells us we've got 4 carbons in it. So we draw 4 carbons in a row. We make sure that each carbon atom is making 4 single covalent bonds, and then we stick hydrogens on the ends of them. So they're the answers you should have. I'm going to put it up a little bit more neatly so that you can review your answers. So there it is, all drawn out nicely rather than by me. So if you'd like to pause the video now and just check that your answers are correct and check that you understand where they came from, we will move on to the final little bit of this tutorial. Okay, so the last little bit of this tutorial is all about something called general formula. So hydrocarbons, various organic molecules, different organic compounds, they all have a general formula, and the general formula allows you to work out the specific formula for anything within the same family. So the family of alkanes have this general formula here, CnH2n plus 2. And what this tells us is N is the number of carbon atoms that's in it. Okay, so if I give you an alkane that you've already seen, there's propane, C3H8. As you can see, this number here is how many carbons we've got. So in this one, N is how many carbons we've got. Then what we do is to work out H, we do 2N plus 2. So it's a bit of algebra. 2 lots of N, so whatever that number was, and we add 2. So let's see if this works for propane. Here's our propane formula. So N, I can see, which is here, is equal to 3 in this case. So if I want to work out the H's, I do 2 times 3 plus 2, because 3 is my N. So 2 times 3 is 6, add 2 on, gives you 8. So it works for propane, and it works for all the alkanes, and that's why it's the alkane general formula. So we're going to do another table. We're going to look at the alkane, how many carbon atoms it's got, which we know we're calling N. We're going to do some algebra with its general formula like this, and then we're going to figure out what its molecular formula would be. So I'll show you the first example now. So we've got methane. That's our alkane. We know that N is equal to 1 because methane only has 1 carbon in it. And then the general formula tells us, if we go back up to here, let me clean that up a little bit. So if we go back up to this general formula here, it tells us that whatever N is, we double it and we add 2, and that'll be the H's. So what I've got is a little bit of maths going on here. So C is 1. Oops. C is 1. That's our N. So N goes here, 1. And then we're doing 2 lots of 1 plus 2. That's our maths. So in the final column, we've got a C with a 1. Now we don't need to write the 1 in because we never do that in chemistry. And then we've got H, and we've got 2 times 1 is 2, plus 2 is 4. And we end up with the molecular formula CH4. So by knowing how many carbons are in it, we can determine what its molecular formula will be if we know the general formula, which is up here. And that's not so handy at the moment because we know that methane is CH4. I've shown you it lots of times during this tutorial. But if I said to you, I've got an alkane, it's got 27 carbons in it, what's its molecular formula? You could use this general formula to work out how many hydrogens it would have and therefore what its formula would be. So let's have a look at another one. Okay, question 2 is ethane. So ethane has got 2 carbon atoms, so N is equal to 2. So if we're going to plug numbers into this general formula, Cn, well, N is 2. H, 2 times N, well, N is 2, plus 2. Let's do the maths. We've got C with a 2, then H, and in brackets we've got 2 times 2 is 4, plus 2 is 6. So we end up with it like this. Next one, we're going to jump all the way to hexane. So you've not heard of hexane before, you've probably heard of a hexagon though. So hexane has 6 carbon atoms. So N is equal to 6, so Cn is C6. 2 times N plus 2 becomes 2 times 6 plus 2. And that's how we work out our molecular formula. So we've got C6, which is there, then an H, and then we have to work out these brackets. 2 times 6 is 12, plus 2 is 14. So I can tell you that hexane has the molecular formula C6H14. And one more before I ask you to do some. Decane has 10 carbons in it, so N is equal to 10. And our general formula is CnH 2 times N plus 2. So C, N is 10, H, 2 times N, which is 10, plus 2, and we can figure that out. So molecular formula, we know we've got 10 carbons in it. For hydrogens, it's 2 times 10 plus 2, so it's 22. And there you go, that's how you work out molecular formula. Now, I've gone fairly quickly. If that's confusing, go back and watch me do all of this bit again. If you want to make any notes, you can make a couple of notes because what I'm going to do now is give you another table very similar to this one, and I'm going to ask you to work out the molecular formula using this general formula up here. Okay, your turn, and this is the last little bit that we're going to do. So I've given you some alkanes. So we've got octane, which has 8 carbons, nonane has 9, dodecane has 12, tridecane has 13, and nonadecane has 19. So these are your letter N's. Here is your general formula. Can you plug in some numbers and work out what the molecular formula would be for octane, nonane, dodecane, tridecane, and nonadecane? Pause the video now, either draw out the table or you can write it just in rows, that's up to you. And in a moment I will review it with you just to finish off this tutorial. Okay, so octane has 8 carbons, so I know it's going to be C8. I know it's got hydrogens, and the number of hydrogens is 2 lots of N plus 2. So that's 2 lots of 8 plus 2. 2 lots of 8 is 16, add 2 is 18. Nonane has 9 carbons in it, so it's going to start C9. H is 2 lots of 9, which is 18, plus 2 takes up to 20. Dodecane has 12 carbons in it, and then for hydrogens we double the 12 to 24 and we add 2 to 26. Tridecane has 13 carbons in it. It also has some hydrogens, and to work out the hydrogens we double 13, taking it up to 26, and we add 2 to take it to 28. Nonadecane has 19 carbons in it, and it's also got some hydrogens. So we are going to double the 19 up to 38, and we're going to add 2, and that will take us to 40. So the molecular formula for octane is C8H18, nonane's formula is C9H20, dodecane is C12H26, tridecane is C13H28, and nonadecane is C19H40. And I've been able to do that without having to draw 19 carbons in a row and stick hydrogens all around the outside, because if I had to do it by drawing the displayed formula, that would take me a really, really long time, and that's where these general formula come in handy. So as well as the key definitions and the names of the first 4 alkanes, methane, ethane, propane and butane, this is another thing for you to learn. CnH2n plus 2 is the general formula for alkanes. Okay, so that's the end of that tutorial. That covers an introduction to organic chemistry and puts us in a position where we can start to look at how to separate out all of these alkanes when we get the crude oil out the ground. In the meantime, between now and the next tutorial, what I would recommend you do is just make sure that you do remember that the first 4 alkanes are called methane, ethane, propane and butane, and make sure that next time you do a tutorial you're able to just list those names in order off the top of your head. One way to do that is with a mnemonic. So some people remember monkeys eat peanut butter, and there are loads of other mnemonics for it as well. You can make up your own if you want to, but that would be a challenge between now and the next tutorial, is to remember these names in order. 1 carbon, 2 carbons, 3 carbons, 4 carbons. Thank you for watching this tutorial.